So today we're gonna be doing the week 3. Are we week 3 or 4? Week 3, yeah? Week 3. Yeah, we're doing the week 3 AS CHEM quiz for the AMS tomorrow. So most of this quiz, other than like 7-8 questions, is all repeat. So I'm gonna skim through them really fast, explaining. And yeah, for the rest I'll explain. So the ones that are repeat, they're all from the AP material we did last week, and the new ones are all about group 2 metals and their properties. So I'm gonna begin now. Which of the following ions have 3 different numbers of all 3 subatomic particles? What you're gonna have to do is find the number of protons, which is the bottom number, and then, so you have 16 protons. And then you need to find the number of electrons, which is 16 plus 2, because it's 2 minus means you have to add 2. So it is 18 electrons. And 32 minus 16 will give you the number of neutrons. We already should all know this. 16 neutrons. So this, you have 16 and 16, they're the same number. You're going to do the same exact thing. Here you have 7 protons and you have 7 neutrons. So already it's the same. Here you have also 12 protons, 12 neutrons. So they're the same. Here you have 19 protons, 20 18 electrons, and 20 neutrons. So all 3 numbers are different. So this is your correct option. Now deduce the number. Now for this, we already did it last week. It's just basically, for this entire row, you copy the top number. For this entire row, you copy the bottom number. The bottom number. For this entire row, you copy this number. Like, these are in every single case scenario. In no case scenario will you have it any different if they ask with these titles. Now for number of electrons, you see, if it does not have a charge, you copy this number, like in these 2 cases. But if it has a charge, let's say it has a negative charge. If it has a -1 charge, you add 1. So this is 35. So it has a -1 charge, so it becomes 36 plus 1. Now here you have a 26 and a 2 plus charge. If it has a 2 plus charge, you minus 2. So 26 minus 2 gives you 24. Now to find the number of neutrons is maybe like the hardest, or not hardest, but like most work you have to do, which is the top number minus bottom number, top number minus bottom number, top number minus bottom number, top number minus bottom number. Do that onto your calculator, you will be getting all of their answers correctly. Let's move on to the next question. Now, the new questions are mostly between questions 10 and 17, with a few exceptions after that, but barely any. Now, which of the following is true? The number of neutrons is 26. 48 minus 22 is 26. So this one is true. The atomic number is 48. No, it is 22. So this is wrong. Mass number is 22. No, it is 48. So this is wrong. Number of protons is 26. What did I say? Number of protons is bottom number. So not 26. The number of electrons is 48. No, it is 22, because it's the same as the bottom number. The top number, which is the mass number, is equal to protons plus neutrons. They're called nucleons. So the top number is the number of nucleons. Moving on. Copper is a transition metal that has 29 protons and 35 electrons. Since 29 protons, 29 has to be the number on the bottom. And the number on top is going to be the number of protons plus neutrons. So that is 64. Let us move on to the next question. Now here we have to use a formula. The surface of a metal is struck by electromagnetic radiation of increasing energy. They have the energy of the photons is equal to this. And they gave us Planck's constant, and they gave us the speed of light. Now we need to use the formula energy equals hc over lambda, which is wavelength. Here they're asking us what is the wavelength. So we know everything but the wavelength. So energy is 4.19 to the power of 10 to the power negative 19. So 4.19 times 10 power negative 19. H is 6.63 times 10 power negative 34. That is all times 3 times 10 to the power of 8 all over wavelength. Put this all into your calculator. You should get an answer of 4.75 times 4.75 times 10 to the power of 7, if I'm not wrong. Or is it negative 7? Negative 7. No, I'm not sure. You're gonna either get 7 or negative 7. Either way, it's negative 7, isn't it? Because when you move from... Guys, just when you do it to your calculator, either way, you're gonna get the answer in meters. So when you make meters to nanometers, the number gets bigger. Yeah, so it's negative 7. Of course, negative 7. Now I just realized. So now when you're moving it to nanometers, you multiply by 10 to the power of 9. 10 to the power of 9 makes it 4.75 times 10 to the power of 2, which is 475. Now for the next part, you need to see 475 is between which of these ranges? It's definitely not between these two, nor these two, nor these two. Now is it between 491? No. 424 and 491? Yes, so it is a blue light that has this wavelength. Moving on. Now, what's true about isotopes? They have different number of neutrons. They have the same chemical properties. Why though? If they ask you why do isotopes have the same chemical properties, it is because they have the same electronic configuration. So this is true. They have the same number of protons. Of course they do. If they didn't have the same number of protons, they would be two completely different elements. Not even isotopes. They have the same physical properties. No, they don't. If they would have had it, what's the point of an isotope anyways? Now, we have degenerate orbitals. Now, what's the following is true about 2px and 2py? Whenever you see the same letter in the same n, which is the energy level, you need to know that it is basically, if you watched my last video, you know that I split them up into houses. One house has 3 rooms. Now, when we want to name the rooms, we have to name them. So, let's say this is the p orbital because it has 3 rooms. This is called px. This is called py, and this is called pz. Oh, last time, by the way, they got us a question and they asked us what's the shape of the pz orbital. This was the z-axis, this was y, this was x. If it's pz, it has to be a dumbbell on the z-axis. If it is py, it has to be like this. If it is px, it has to be like the infinity sign. So that's just a little side note. Anyways, so these little houses have names. These names belong to the degenerate orbitals. That's what they called. The little rooms in each house are degenerate orbitals. And they have the same energy and sublevel because they have the same number n. Moving on. Okay, so what's the number of protons, neutrons, and electrons? Okay, so this is very easy, like I said. Bottom number is the protons. And if you don't have a charge, it's also the electrons, my bad. 80 minus the top number minus bottom number gives you neutrons. Now 137 minus 56 gives you the number of neutrons, and 56 minus 2, because you have 2 plus, gives you 54. Now 17 plus 1 gives you 18. That's the number of electrons. And 35 minus 17 is also 18, so that's also the number of neutrons. Let us move on to the next question. I'm skimming through these because we already did them all last week. Now here, most of them are the same as we did last week, except we have 2 new concepts, which are the ionic configuration. Here, they already gave us up till this point. This was all given. So, in case you didn't watch my last video, I'm going to explain how do we write this if it was given to us to write from scratch. We use the SPDF backwards method. What does this mean? This means you go backwards twice each time. So our letters will be S, then P, so you go backwards. So P, S, P, S. So P, S, P, S. And then DPS, DPS twice. DPS, FDPS. Then FDPS, FDPS. And that's how you just write them. This is the entire thing. For the entire periodic table, this is how it's written. Now, we have something. So when you start, S always starts with, the first S starts with 1. Second S, 2. S always has a superscript or like an exponent of 2. P always 6 when it is filled. When it is filled, it has an exponent of 6. So D always has an exponent when filled of 10, F of 14. Now, the first P does not start with 1. The first P starts with 2. The first D starts with 3. And the first F starts with 4. Because they do not show up until that energy level. So that's just a quick preview of how do we write them if you didn't know. So like I said, this part was all given. You need to now count how many exponents how much do you have in the exponents. So you know how to continue. 4, 10, 12, 18. So up till here you have 18 electrons. Now 29 minus 18 is gonna give us 11. Now look, usually you just continue normally until you reach 11, except we have 2 exceptions, copper and chromium. Their d orbital for copper and chromium, their d orbital always has to have a superscript of 5 or 10. Nothing more, nothing less. So here, if this was not copper, we'd have to continue 4s2, 3d9. But since this is copper, copper cannot have other than 5 or 10 in its d orbital. So here you have to make it 10 and steal 1 from here. The exception of this is only for copper and chromium, no other thing. So 4s1, 3d10. That is it. You continue on. And now let's move on to the next example. Now this is an ion. For the ions, I need you to focus. You start off the exact same, but you move on not the exact same. So here, till here again, it was given. These are the first 18 electrons. Now how do we continue? Let's forget there's an ion and continue it normally. 26 minus 18 should be, what's it called? 2 is 20, so 26, so we need 8 more. Yeah, 8 more. So if we were to continue it normally, we start from 4s2 to need 8 more, so 3d, 8 minus 2 is 6, so 3d6. This is if we were to write it as an atom, but here it's an ion. Since it is an ion, you will do one thing. First of all, look at your highest energy level. When I say highest energy level, I don't mean highest letter, that D is higher than S, so D is the one we take from. No, the one with the highest number, which in this case is 4. You look at 4, you take. So here it's 3 plus, so you need to take from it. So you need to take 3 from it. But 4S only has 2. So you'll take 2 from this and cancel it out. We do not write it anymore because it has no superscript. And you will also take your next one from the next most powerful. So here we have 3 3s. But the 3 with the biggest letter, so D or F, is the one you're going to take the 1 from. So this becomes 3d5. And this one, like I said, we cancel it because it has no superscript. So we're left with 3d5. Now, let's say you had 4s2, 4d5, let's say. Then you do not take anything from 4s2. You will straight away take from the biggest. The biggest is, first of all, you need to check the number before it. The one with the biggest number you take from. If there's more than one with the same big number, you look at the letter. F first takes. If there's no F, take from D. If there's no D, take from P. If there's no P, take from S. Let us move on to the next one. Calcium, we just continue it normally. Here till here was given again. These are 18. 20 minus 18 gives us 2, so we only need to continue 4s2. Now we have 20 electrons. Moving on. Selenium is S2 minus. Now, like I said, again, we write it how we normally write. So till here is 18. Since till there is 18, we need to find how much more needed. So I think it's 16, if I'm not wrong. Yeah, we need 16 more. So, first of all, we continue. So 4s2. Then 3d10. Till now we're at 12. Then 4p4. This is if it were an atom. We are treating them like atoms first. Now we need to see the charge. What's the charge? Se2 minus, which means we need to give it 2. Now we look. First of all, the number. The highest number we have is 4. Since the highest number we have is 4, we have 2 4s. So what 4 will we give it to? The S or the P? I said you give it to the bigger letter. So we're gonna give 2 to the P. So now this is gonna become a 4p6. Now do we have a full shell? We have a full shell. We can move on now to the next question because we're done. This one. Now identify the shapes of the S and P orbital. S is gonna be sphere. P is gonna be a dumbbell shape. This shape is gonna be for the D orbital, and for the F orbital it is a complex 3D shape. And that's it. Let's move on to now. These are the new questions that are in the AS material only. Now we need to know of few things. Magnesium, it's a metal, of course, in the group 2. Now it reacts, they're telling you, it reacts very slowly with cold water but vigorously with steam. Now for the reactions, you need to tell you what's the reaction between magnesium with cold water and it with steam. Now since it's very slowly with cold water, we're gonna act like it's gonna take more time to actually do the reaction. So it has time to take OH2. Like, it's just memorize it, honestly. It's an equation with liquid water, which is cold water. It makes MgOH2 because OH has a charge of 1. And it needs, so here you can't use this, so you need to use 2 of it. So 2H2O. So then you're left with H2. So our products are going to be MgOH2 and H2. Now when it reacts with steam, since it's vigorous, it's quick. So we're going to act like it does not have enough time to take that extra H. So it just takes MgO. The H2 that are left, it leaves. So it's just Mg plus 1 H2O. So it's MgO and H2 goes alone. So that's your second product. So with cold water, it has the time to take the extra H. So it becomes MgOH2. And with steam, it's vigorous. So it takes only MgO because it wants to finish fast. That's not really what happens, by the way. I'm just like giving you a way to memorize it. Now, we know any metal with an acid, what does it produce? A salt and hydrogen. Metal plus acid. So metal plus acid, or H plus, I'm gonna write, forms salt plus H2. So Mg is always a solid. Plus 2 HCl, this is balancing, later we do it. Plus 2 HCl gives you MgCl plus H2. And Cl2, because Mg has a charge of 2 plus, Cl 1 minus. So you have to do the crisscross method. The 1 goes to Mg and the 2 goes to Cl, so it becomes Cl2. And since in the product you need Cl2, here you need to add the 2, because you also have H2 gas. And of course, do not forget your state symbols. Again, now here you have with a acid again. Like I said, metal plus acid, salt plus H2. Now, Mg plus H2SO4 will be MgSO4, and SO4 has a charge of -2, so you don't need to add any more SO4, plus H2. Again, it's the same as the one above it, it's just a different example. Now with O2, look at it, Mg plus O2. You need since O2 is 2, and you can't have MgO2, you need to have MgO. Since it's O, you need 2 moles of MgO. And just like combining, it's like math, honestly. Let's move on. This question is really easy. Now, okay. So here we have a positive plate, a negative plate, a subatomic particles, whatever. This is old material, but it was, yeah, anyways. So, since this is protons, protons are attracted to negative things. So Y has to be the negative plate. So if this is protons, it has to also repel something. It repels the positive plate. What attracts the positive plate? A, which is electrons. Since protons are here, electrons are there, what continues undeviated? It is neutrons. So X is the positive plate, Y is the negative plate, A is the electrons, and B is the neutrons. Now electrons have a symbol of E minus, neutrons have a symbol of N0, protons have a symbol of P plus. Now electrons are very light. They have a mass of 1 over 1836. Neutrons have a mass of 1 like protons. And for their charges, electrons are -1, and neutrons have no charge, and protons are +1. Moving on. Next question. Now we need to know the properties of the group 2 metals. Now I'm gonna write down the list of the group 2 metals as they are in the periodic table. So first group 2 metal we have is beryllium, then magnesium, then calcium, then Sr, then beryllium, then radium. Now, when we're talking about these metals, there's some certain trends. As we go down the group, the melting point, it will decrease. But there's a slight thing I'm gonna show you at the end of the video. I'm gonna open the book for chem and show you the tables because I can't really explain them. But you need to really memorize them. So generally, melting points as you go down decreases. Atomic radius as you go down will increase. So atomic radius. Now atomic radius will increase. Why? Because as it's getting bigger, as the atom is getting bigger, it's gonna have more shells in the electron. So it'll have a higher atomic radius. So it's greater than, melting point is less than. The ionizing energy as you go down will decrease. So ionizing energy decreases as you go down. So beryllium will have a less ionizing energy than Ca. Now the reactivity as you go down will increase. Reactivity increases. So just memorize these for now. There's more, but I'll tell you them when we reach questions that can show you why. And I need to show you the melting point and the other thing in the book at the end, but now I'll leave that for the end. Now, X was analyzed by the percentage mass of barium, which is 81.1. X reacts with dilute H2SO4 in a 1:1 ratio. Now, for this question, there's a tiny trick. You need to be careful when they told you that the percentage by mass of barium is 81.8. Because here, if I read it when I read it the first time, I just put BaO because I saw it not seated strongly in oxygen. But let's see something. When you put BaO, Ba has an atomic mass of 137, O of 16. Add them together, you're gonna get 153, if I'm not wrong. Yes, 153. When you do 137, divide 153, is 137 81.8%? No, it is 89.6%, I think. If I'm not the number point something is wrong, but I'm not sure. It's over 5. So it is almost 90%. Here they told you the percentage of mass of barium is 81.8. So what do? We need to assume it is O2 because there's no oxygen left. You can't take one oxygen with the other. So the second oxygen, you took it BaO2. Now if it's BaO2, it's 32, which is gonna be 169. 169 over 137. Or sorry, 137 over 169. How much is it? Is it now 81? Now when you do it on your calculator, this is gonna equal 81.1%. So we know that it is BaO2. So that's why compound X is BaO2. Now to get Y and Z, so now you have BaO2 reacting with dilute H2SO4. Now what are your products gonna be if one is a solid and one is aqueous? We know that barium sulfate is insoluble because sulfates are insoluble with barium, calcium, and silver. So it is gonna be BaSO4 for our first product. And now we have what's left? We have left H2 and O2. So H2O2 is our second product, which is hydrogen peroxide. This question you can't really know, you just have to actually solve it to know. Moving on to our next question. Now, question 13 has a small mistake in the end. I'll tell you it when we reach. Elements in group 2 are known as alkaline earth metals and they exist naturally bonded to each other. Now, as you go down, the reactivity we said increases, the melting point decreases, the first ionizing energy decreases, atomic radius increases. I already mentioned all of these. Now, let's move on. Now, write the chemical equation of the reaction between calcium and oxygen gas. So, Ca plus O2, it's gonna make CaO because we don't need the O2. We can't, it can't be CaO2 because Ca has a charge of +2 and oxygen has a charge of -2, so you can't put O2. So CaO, and since you have 2 here, what are you gonna do? You're gonna add 2 here and 2 here. So now you have 2 Ca plus O2 gives you 2 CaO. Now let's move on. Now drag and drop the values of the saturated solution of hydroxides, arrange their increasing order of pH values. Now as you go down the group 2, the solubility of metal hydroxides increases. So solubility of metal, I'm just gonna write metal OH because that's metal hydroxides, increases. So they become more soluble. If they're more soluble, that means they release more OH ions, which means they raise the pH. So we said that the order is Ba, Be, Mg, Ca, Sr, Ba, and radium. So as we go down, the solubility increases. So the least soluble is the one that's most up. So Mg is the least soluble. Calcium comes next, and Sr comes next. And they form ionic compounds, definitely not molecular because they are metals. Now last part, this is where there is a mistake. Calcium, when you put it in a flame test, it does give you a brick red color. But strontium does not give apple green. It gives you a scarlet red color. Take note. I'm actually going to give you all of them, what they give you colors. So, Mg gives you white flame. Ca, calcium, gives you brick red color. Sr gives you scarlet red flame. And barium gives you pale green color or apple green color. Pale green. That's the colors of all of them. Now let's move on. In the next question, I think, or the question after that, it's the exact same type of question. No, this one is the exact same question almost, with a few differences. Now, the charge of their ions across the group will always be 2+. So it remains constant. The density as you go down increases. So melting point decreases, density increases. Memorize. First ionizing energy, we said it decreases, and atomic radius, we already know it increases. Let us move on. The elements of group 2 burn in air, rapidly forming oxides. Now here they want the exact same thing as the last question, except with Mg, you do the exact same steps. Mg plus O2 to MgO. I'm not going to explain. Now, which of the following has the highest order of solubility of the hydroxides? Like I said, it's as you go down, it increases. So Mg is on top, Ca is under Mg, and Ba is even under both of them. So that's why it is the most soluble in hydroxides, as a hydroxide. And they form ionic compounds. We said strontium scarlet and barium apple green. Now, complete the following table. The species that has 12 protons, or aka that has an atomic number of 12, is magnesium, and 38 is strontium. Now the solubility increases of the hydroxides. Now the pH of a what's it called, a hydroxide that is below another one is gonna, like I said, they release more OH ions, so it's gonna be a higher pH. So Sr is under Mg, so it has a higher pH because it can release more OH ions. And that's it for this question. Let's move on. Oh yeah, so here when Mg reacts, heats gently in oxygen. When it heats gently in oxygen, it's just gonna be 2MgO is your product, so it is MgO there because they don't want you to know how much. So it's just MgO. Now when you add H2O to MgO, it's gonna form MgOH2, and that's it. It's just gonna form MgOH2. Why? Because OH has a charge of -1. Mg has a charge of +2 plus. That's why. And now we need to also, like, we don't need to balance because you have here 2 O's and 2 H's. So it's perfectly balanced. Moving on. When you add compound U, which is compound U is MgOH. MgOH is a base. When you add it to a HCl, which is an acid, what do you form? MgCl2, right? Because the H2O, when you have an acid and the base, what do you form? A salt plus water. So the OH2 is gonna be, it's gonna react with the H to form 2H2O. You need 2 HCl. Oh yeah, this question you actually need to balance. So MgOH, you need 2 Cl2. So you need to multiply this by 2, and this by, sorry, not this, this by 2. Wait, do we need to multiply that? No, wait. My bad, you only multiply HCl by 2. Since now you have 2H2 and 2H2O, 2OH and 2H, that can make 2 ions of H2O, but you don't really need to care about the H2O. Anyways, you need 1 mole of U with 2 moles of HCl to form the product MgCl2, and it is an aqueous solution. Now the same thing with HNO3, it is also an acid, Mg into OH2, sorry, plus plus NO3, HNO3. I keep mixing up. Now HNO3, now when you add them, NO3 has a subscript of it's NO3 minus 1. So NO3 minus 1 means it's Mg2 plus. You're gonna crisscross method, so it's gonna be MgNO3 2. So that's your product, also aqueous. So you need 2 HNO3 because now you have 2 moles of NO3. So you're gonna produce MgNO3 2 and water, but we don't care about the water. It's also going to be in a ratio of 1 MgOH to 2 NO3s. Now with H2SO4, SO4 has a superscript of 2 minus Mg, 2 plus. They cancel out, so it just forms MgSO4. It is an aqueous, and since they cancel out, it is a 1-to-1 ratio. If you write aqueous with a capital A, by the way, it gives you wrong for some weird reason. Now, formula of the compound formed with, okay, so MgOH2 formed with NaCO3. Mg, then you're gonna form just MgCO3 and NaOH. And that's it. That's literally what they want. So now we move on. Radium is just below barium in the periodic table. So we said density as we go down increases. So it's gonna have a higher density. So yes. Atomic radius we said also increases. So AR increases. Second ionizing energy of Ra is smaller than the second, yes, because it decreases. Ionizing energy decreases. Melting point equal, definitely no. Moving on. I think this is the last new question that's like part of the AS only material. Now, radium sulfate is insoluble in water. Let me see if I have a rule about this. Now I know as we go down the group that the solubility of metal sulfates in metal SO4 sulfates, it decreases as we go down. So radium is the last one. So it is insoluble in, it cannot make a sulfate, but that has nothing to do with water. I'm just telling you a fact that was written in my copybook, so I think we should know. Now, radium sulfate is insoluble with water because it cannot react with it. Now, moving on, RaCl2 turned into Ra plus Cl2. Now, RaCl2 had Ra plus 2 and Cl minus 1 because Cl stays the same since it is in group 7. Ra is plus 2. We already know this. Now, Ra, when it becomes Ra as an atom, it has an what's it called? Oxidation number of 0. Cl, when it also becomes an atom, it has an oxidation of 0. But in Ra, it decreased. It became less. But in Cl, it increased to become 0. So if Ra decreased, it got reduced. The thing that gets reduced is the oxidizing agent, and the thing that got oxidized, aka Cl, is the reducing agent. And here's the thing I explained up. The solubilities of sulfates decrease as you go down, but the reactivity increases. The reaction of radium in water is vigorous. As you go down, the reaction of radium with water is vigorous. Oh yeah, I need to mention why it doesn't. Right now I remember why it doesn't react with water. Now this is with sulfates. Sorry, my bad. I remember having a note with water. Okay, yeah. So with O2, they react vigorously when burnt with oxygen, and they form solids and bright flames. With water, Mg, it forms if it's with cold water, MgOH, with steam, MgO. Ca reacts with cold water to form CaOH, and yeah, I don't mention anything else. And it's CaOH2 is called slacked lime. I'm reading out my notes, by the way. Now, calcium, strontium, and barium sulfates are insoluble in hydrogen sulfate. Why? Because a layer will form on the metal, slowing down the reaction until it stops reacting completely. Now, I have nothing about why it's insoluble in water, but memorize it for now. Now write the reaction with water. Since it's insoluble, it's gonna form an aqueous solution. Wait, what? It's insoluble in water. Yeah. Now, I was confused right now, because radium plus 2H2O gives you a aqueous solution, which means it is soluble in water, and when I searched it up on Google now, it says it is soluble in water. So, it's either there's a trick in the question that makes it insoluble, or that the question is wrong and it is actually soluble. So, this I will email my teacher about right now, and get the answer. And I will write the answer if it is not wrong and it is actually insoluble in water. I will tell you the answer in the comments when my teacher answers, so check like in an hour or two. But if I do not write anything in the comments, it means that it is a wrong question and it is soluble in water, because here it can't make an aqueous solution if it's insoluble in water. It would have to make a solid solution if it's insoluble. So radium plus 2H2O gives you radium hydroxide, aqueous, and H2. Metal plus water gives you hydrogen and the hydroxide. Now, since radium is a hydroxide that is near the bottom, it is very soluble. Since it is very soluble as a hydroxide, it's gonna have a high pH, close to 14. So it's 12. 12 was the highest option. Now we need to move on. Here we did a question that's the same. Away from the positive plate is protons, away from the negative plate is electrons, and does not deviate is neutrons. Because we took it in physics before, we don't need to explain. Now the proton, we did the exact same question, so I'm going to skim through. Proton plus 1, neutron 0, electron minus 1. Mass of proton and neutron is 1. Electron is 1 over 1836. Memorize. These aren't like anything you can understand. Here, like I said, we did these questions all before. Bromine radius has the mass of a bromine is 80. The atomic number of bromine is 35. So it has 35 protons and 35 electrons since it is an atom. But the number of neutrons is 80 minus 35, which is 45. Let's move on. I don't want to make this video very long because we have taken all of this before. P orbital, I said, is dumbbell shaped. D orbital is clover shaped. S orbital is spherical. F orbital is a weird complex 3D shape. Moving on. Here you have, okay. So last time, I feel like not everyone understood me when I said energy levels, and then we sat talking about SPDF, and that S has a maximum of 2, and P has a maximum of 6, and D has a maximum of 10. You're saying how? So nobody actually said how, but like I was assuming. Some people might have been confused by it. So when we're talking about energy levels, I'm talking about the number before the letter. So it could be 1, 2, 3. So in the fourth energy level, doesn't mean any letter. We don't care about the letters. But in all of the four, like in 4s2 and 4s in 4s2 and 4s, sorry, what? Yeah, in 4s2 and 4p6 and 4d10 and 4p14, what's the maximum number of electrons? This has a formula, 2n squared. So 4 squared is 16 times 2 is 32. Now, when we say that the d orbital can have a maximum of 10 electrons, that's specific to d orbital, not to the energy level. The energy level is the one for all the orbitals of that energy level. So N1 can be only 2, and 2 can have maximum of 8, 3 can have a maximum of 3 squared is 9, 18, 4 we just said 32, 5, 50, and so on. So when I say energy level, it's the number before the letter. Now question 23. What can accommodate? What's the subshell? Not the energy level that can accommodate 10 electrons. It is the D subshell. D subshell is 10, S is 2, P is 6, and F is 14. Moving on. Here we have a mass spectrum. So now here you need to count how many lines do you have, and that's how many isotopes you have. Now, what's the relative mass? You're gonna do 79 plus times 24 over plus 25 times 10 plus 26 times 11 all over 100. Now you do that on your calculator, you're gonna get 24.3, and that's your answer. When you look at your periodic table, the one with 24.3 is magnesium. So let's move on to the next question. Find the percentage abundance of the isotope, which means you need to know that both of them together, when you do the equation we did before, gives you 10.8. So 10 times x plus 11, because these are the masses we have of the isotopes, 11 times 100 minus x over 100 equals 10.81. If you have a calculator, put it all into your calculator. If you don't solve it and put it then into your calculator, then you're gonna get that x equals 19. To find, so that's for the one you gave x. Now to the one you gave 100 minus x, which in our case is the 11, you do 100 minus x, which is 100 minus 19, which is 81. Clear? Should be clear, because we already did this a million times before, so sorry if I'm moving too fast. Next question. Okay, so if it has an atomic number of 90, the charge of the nucleus is how many protons there is. So the protons is gonna be 90. So because there's 90 protons, neutrons have no charge, so they don't affect on the charge of the protons, so you're gonna have plus 90. If it's as charge of the atom, if it is an atom, it is 0. If it is an ion, then that depends on the charge of the ion, plus 2, plus 1, plus 3, minus 3, minus 2, minus 1, whatever, doesn't matter. Moving on. Atomic symbol, we wrote mass number up, atomic number down, and the element or the symbol is there. Moving on. Now this, a bit new. Now here, how to solve it. First of all, we write the entire SPDF of it. So it is 2s2, 2p6, 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and since we have 26, then we need to count 2, 4, 10, 12, 18, 20. Now we have 4 left. So 4p4. Now, this question is wrong again. Last week it was wrong, this week it's wrong. Still. Now, for this question, we need to write shorthand. What does shorthand mean? Shorthand means you take the noble gas closest to this atom and you replace the noble gas in the place of its electrons. So when you look at your periodic table, Fe is close to krypton and argon. But you can't go to krypton because krypton is bigger than Fe. So you go to argon, which is smaller than it. Now argon has 18 electrons. So you need to count till 18. So 2, 4, 10, 12, 18. You put it between brackets. These are the equal to argon. So you just put AR between these two brackets. And then you continue 4s2, 4p4. Like I said, oh wait, it's not 4p4, it's 3d. My bad, because I mixed up really badly. I'm very sorry, because I'm a bit sleepy and I want to sleep, so I'm very sorry. This is 3d4, this is 3d. They got a mistake here in the quiz for the second time. They didn't fix it yet, but it is fine because we know it's wrong. Now, if they ask you to do the ion, you just do the ion on the normal equation. Then you take out what you need. You don't need as shorthand. Then you just put it down the rest. 4s2, this. So argon has 18. 18 plus 2, 20. Plus 4, 26. Easy. Wait a minute, I just realized if argon has 18, then 18 plus 2 is 20. 20 plus 6 is 26. I'm very sorry also because I said 2 weeks in a row it's a wrong question. It's not a wrong question. It's because Oh wait, it's not a wrong question. That was another question that was wrong. My bad, guys. It's a correct question. It is 3d6. I'm very sleepy, if you can't tell, and it is correct. And yeah, it's just like we did. I just counted wrong. So argon is 18, plus 2 is 20, plus 6 is 26. Very sorry. Moving on to our next question. Like I said, this is like the thing I said last time. Wait, but last question is... Okay, last question needs a bit of explaining, so I'll leave it to the end, actually. Now, Ti is titanium, and it has 27... Oh wait, 22? 22, sorry, my bad. They told us 22. So we write down the electronic configuration, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So far we're on 20. Okay, and then 3d2. Now we can do what we said with the shorthand. So we take away 18, which is here. We replace it by argon, because argon is the closest to it. So argon here. And then you're left with 4s2, 3d2. Now we have 2 plus. What did I say? You look at the highest number, which is the highest energy level, 4s2. You take away from it 2. Since it is 2 plus, we take away 2. You're left with 3d2. And that's it. Here, same thing. We write down till 15. So it is 1s2, 2s2, 2p6, 3s2, and 3p... 2, 4, 6, 10, 12, and now we need 13, so 3 only. So now, since we have this, we can take away, look at phosphorus. The closest noble gas to it that is smaller is neon. So we take away 10 till here, and that's neon. We replace it by neon. Now 3s2 goes down, and 3p6 goes down, 3p3. Now we need to give it 3 electrons. Where do we give it? To the highest energy level. We have 2 energy levels that are 3, so the highest letter, which is P, so you give it 3 and becomes 6. And that's it for this question. Next question. Removing 1s electron from oxygen requires more energy than removing 1 from a nitrogen atom, because oxygen has a nuclear charge. What does this mean? It needs more energy than. Why? Because they have a nuclear charge. So oxygen is a bigger atom than nitrogen. So since oxygen is bigger and it has 1 more proton than nitrogen, it has 1 more positive charge pulling in the electrons. It has 1 more +1 to pull the more -1s. So it has a higher nuclear charge, because it has more protons to pull in the electrons that it does have. So since it has more protons, so a bigger positive force, you're gonna need more energy to pull away an electron from the oxygen, because it has more nuclear charge, because it has more protons, more positive charges. And that's it for the quiz, but I need to go back to the book to show you what I was talking about for the group 2 elements. So I'll pause the video, go to the book, and open the video again. Okay guys, so we're in the book. Now, let's see. Now, what I was telling you about the melting points, look. Here in the melting points, it decreases, then increases, then goes back to decreasing. So when you're drawing it, there's a little, like this. So they say that the melting point, when you go down group 2, except for Mg, is decreasing. So you need to memorize that from Be to Mg it decreases, from Mg to Ca it increases, and then the rest it decreases. Now for densities, it decreases, then it increases. So from Be to Ca, density decreases. From Ca to Ba, it increases. So this is what I was trying to tell you about group 2, but I had to show you the graph to explain. And the metallic radius, like I said, increases. So, yeah. Is there anything else in the book I needed to show? I doubt there is. It's just the thing with the density and the melting point. Like I said, it increases as we go down. And yeah, strontium is a scarlet red flame, so the quiz, that question was very much wrong. So yeah. And by the way, here in the book they don't mention anything about strontium being not reactive in water, so I will be, being insoluble in water, so I will be checking with my teacher, but I think it is very much wrong. 90% chance it is wrong. Like I said, check for the comments in an hour or two. If you find any comment from the channel itself, it means that the question was correct and I got a reason why. If it was not, if you don't find anything in the comments, know that the question was wrong. Anyways, that's it for this video. Hope you understood everything. Have a great day. Bye.